Welcome to RT3 Lesson 2, Part 2. In this lesson, you're going to use trigonometry to solve for missing sides and angles, and we're going to use trigonometry to help us then find areas. Let's review SOHCAHTOA. So reminds us that sine is the opposite side over the hypotenuse. Ka reminds us that cosine is the adjacent side over the hypotenuse. And TOA helps us remember that tangent is the opposite side over the adjacent side. We're going to make sure that we have this in the forefront of our brain today, maybe even write it on each problem. Example number 1 says to find the area of the rectangle. I know for a rectangle, to find the area, I need the base and the height. I am only given one part of that, the height, but I've given this angle measure. I have this angle measure, and that angle measure is 29. I am also given the length opposite of it. So if I remember, SOHCAHTOA, I have the opposite, and I want to find what's adjacent. Opposite, adjacent is using tangent. So tangent of 29 degrees equals the opposite, 5, over the adjacent. I'll just call that x for right now. And that's going to give us that side length. Now we need to solve for x. We can multiply both sides by x. And I have x tangent 29 equals 5. I'm going to divide both sides by tangent 29. And I'm going to put this in my calculator. X equals 5 divided by tangent 29. That's going to give me my side length of 9.02. Let's call that 9. Now, if you did not get this, remember, you need to check your calculator for what mode it is in. It needs to be in degrees. This is not the end of our problem because we just found x, we just found that length. Now we need to find the area, which is base times height. So we're going to do 9 times 5 to get an area of 45 units squared. In this example, it says to find the area of the triangle. I know with area of a triangle, I need the base and the height. I have one of those, but I don't have the other. I do have an angle measure, so we can think about SOHCAHTOA again. And I can see I have the opposite, and I want to find the adjacent. So we are going to use tangent again. We have tangent of 59 degrees equals the opposite, which is 5, over the adjacent, which we don't know. Let's call it x. We're going to solve for x. So we have x tangent 59 equals 5, which then means when we divide by tangent 59 on both sides, we have 5 divided by tangent of 59. X equals 3. Now we can recall that the area of a triangle is 1/2 base times height. So I have 1/2 5 times 3. 1/2 times 5 is 2.5 times 3 is 7.5 units squared is our area. Let's take a look at example number 3. Again, we're trying to find the area of the triangle. As I look at this triangle, I don't see any 90-degree angles, which means we need to see if we can create another triangle that has a 90-degree angle. So we're actually going to make a 90-degree angle here. And as I look at this, I see that the two bases are the same angle measure. So the two angles on the bottom are both 36, which means we have an isosceles triangle. There's that special relationship in an isosceles triangle. When I drop an altitude in the isosceles triangle, first of all, an altitude always makes that perpendicular. But in an isosceles triangle, it has a special relationship, so it cuts the other side in half. Okay, so this length will be 5. Now, as I look at this, I can see that I need to find the height of the triangle. If I can find the height of that triangle, then I'll have enough information to find the area of the triangle. Again, I'm going to think back to SOHCAHTOA because I see that I have a triangle. We're going to work with this triangle over here. I see that I have an angle. I have the adjacent, and I want to find the opposite. So opposite and adjacent, I'm going to use tangent. Tangent of 36 equals the opposite, which is h, over the adjacent, which is 5. To solve for h, I'm going to multiply both sides by 5. I get h equals 5 times the tangent of 36. From here, I'm going to put this into my calculator, and I'm going to get a height of 3.6 when I round to the nearest tenth. Area equals 1/2 base times height. Now we're going back to the original triangle, the big triangle here. And I know that my base is 10, and we just found the height to be 3.6. So now we're just going to multiply, and we get 18 centimeters squared. Example number 4, find the area of the rhombus. So you got to think back to the fall when we talked about rhombi. And in a rhombus, if we connect the diagonals, it should be a straight line there, but they meet at a 90-degree angle. They meet at a 90-degree angle. In addition, the diagonal bisects the angle. So this angle here is half of 114, which is 57 degrees. Now, another thing that is important is that they bisect. So this length will be equal to this length, which means this is 5. If the whole thing was 10, half of it would be 5. And now we can again think back to SOHCAHTOA. I have my angle of 57. I have what's across, and I need to find the adjacent over here. Because remember, I am just looking at this triangle here. If I'm looking at opposite and adjacent, that's here with TOA, so that means I'm using tangent again. Lots of tangent today. That will not always be the case, but today we've got lots of it. Tangent of 57 is equal to the opposite, which is 5, over the adjacent we'll call x. Multiply both sides by x. So I have x tangent of 57 equals 5. Divide both sides by tangent of 57. I get x equals 5 over tangent of 57. Put that into our calculators, and we get x equals 3.2. Now, if we think about our rhombus a little bit, we could find the area of this triangle right here, base times height divided by 2. And what's going to happen is we actually have 4 of those exact same triangles that make up this entire rhombus. So I could find the area of 1 and multiply it by 4. You could, of course, think of it as finding the 1, not dividing it by 2, and then multiplying that by 2. But I'm going to show you the way that I was talking about first. So we're going to find the area of 1 of them. 1/2 5 times 3.2 to get 8. So that's just one of those triangles. I'm going to take 8 and I'm going to multiply it by 4 because there's 8 of them. So 32 units squared. In example number 5, we need to find x and we need to find y. And we're giving some of the pieces, but we have to figure out some of the other ones. So as I look at this, I know I have this angle, but I don't have any of the other sides. So I need to think, what could I do? What could I use to maybe find those sides or find information to help me on the other triangle? Because in the other triangle on the other side, there's no angle measures except the 90 degree. As I can see here, I have a triangle. And I know that the angle measures have to add up to 180. So I know that this angle measure here will be 47 degrees. And since I know that it has to add up to that 90 degrees, I can find this one to be 43 degrees. Now, from here, I can actually find y. And once I find y, it'll help me find x. Because I want to find y, and then I'm going to find this length, which will help me then to have enough information to find x. So let's remember SOHCAHTOA. And we have our angle, we have what's opposite, and I want the hypotenuse. So opposite and hypotenuse. That is sine, so we're going to use sine of 43 degrees equals the opposite of 8 over the hypotenuse of y. We're going to multiply y on both sides. So I have y sine of 43 equals 8. I'm going to divide both sides by sine of 43. Gives me y equals 8 divided by sine of 43. And I'm going to put this into my calculator, and I'm going to get y equals 11.7. And yes, that's rounded to the nearest tenth, of course. So y is 11.7. Now I can use that information to find this length here, which is actually going to help me find my x. So let's call that length h. Let's call that length h. And as I look at it, using my angle of 43, I have opposite and I have adjacent. So again, we're back to tangent. Tangent of 43 equals the opposite over the adjacent. Multiply both sides by h. We get h times tangent 43 equals 8. Divide both sides by tangent of 43. We get h equals 8 divided by tangent of 43. Put this all in your calculator and you get h to equal. Let's round to the nearest tenth and we get h to equal 8.6. This is my h, which is my height. Now we have enough information to find x. So I'm going to go back over here. We're going to use angle measure 43. We have the opposite and we have the adjacent. Again, going back to tangent. This will help me find x. So tangent of 43 equals the opposite over the adjacent. I'm going to multiply both sides by x. X tangent of 43 equals 8.6. Divide both sides by tangent of 43 and we get x all by itself. 8.6 divided by tangent of 43. X equals, and we get, when we round to the nearest tenth, x equals 9.2. So we found x to be 9.2 and we found y to be 11.7. And in this case, we're done. But if this problem asked you to find the area, you have all the information now to find the area of the triangle because we have the height. You would add x and 8 to get the base, and then you multiply those and divide by 2.